Okay, so let's continue with this. So these expressions are usually they mean something. So one of the things that we do more recently, when I first started teaching algebra, we would just say 2x plus 3x, equals y plus 4y, and nobody really had a context. And nowadays we do what those numbers represent. So those last two examples, we said the cost of the pineapple was $5, and that's what five meant, and 4.49 $4.49 was the cost of watermelons, and then we'd write this expression, and it seemed to make a little more sense. But the algebra part is just the math, right? You're going to have coefficients, you're going to have terms, and you're going to have to move them around algebraically. So for example, 1a, it says x plus y and 2x. The expression 2x is greater. Okay? So how do I set that up? Well, I got to jump up to the top. So it says I'm sorry, I skipped this. It says suppose x and y, we got to read this part here. So suppose x and y give the populations of two different cities where x is greater than y. Okay? So x is greater than y. So let's circle that because we're going to have to come back to that. We're saying that x is greater than y. Compare the expressions and then figure out y. So if x is greater than y, so you could think of it like this. X plus y, that's one expression. And then the other one that we're comparing is 2x. And we're trying to determine which one's greater and which one's lower. So I've got x plus y on this side, but 2x, I don't know if you guys remember this, actually represents x plus x, doesn't it? Well, we know that x is greater than y. So there's a couple of ways you can handle this. You could solve it algebraically, or you could use common sense. So I could just subtract x on this side, and if I subtract x on this side, right, what I'm left with, this cancels and this cancels, and I get y is something compared to x. But we said x is greater than y, or this expression is less than x, and that's where they get 2x is greater. Because this x is greater than this y, so this sum over here will always be greater than this sum. Okay? So putting the lesser population y together with the greater population, x gives a population that is less than double the greater population. So again, let's look at this step. We said x over y and y over x. So we're trying to figure out what's greater. So this is a little more challenging. It says since x is greater than y, then x over y, in other words, this will be an improper fraction. This will be greater than y, and so it'll be a mixed number because it'll be greater. And if you don't know, you can just plug a number in. If I say x is equal to 3, then I could say y is equal to 2, right? And in this case, x is greater than y, so I would say x is equal to 3, x over y can be equal to 3 over 2, but then if I say y over x, I'm going to say 2 over 3. If you plug those in a calculator, you'll see that x over y will be greater. So sometimes when you're not sure how to do things, you could just plug in some numbers and see what works. It has to be greater than 1 because x is greater than y. So whenever you have a number on the top that's bigger than the number on the bottom, you're going to get a number greater than 1. Now on this one's going to be less than 1 because the number on the top is less than the number on the bottom. And remember, you're dividing the numerator by the denominator. So then if this is greater and the other one's less than, then we would say x over y is greater than y over x. So now this one's going to be kind of challenging. Let's try to do 5 and 6. Let's read this. It says, suppose X and Y have two different, or populations of two different cities where X is greater than Y and Y is equal to 0, or greater than 0. That means that Y is positive. Okay? So same thing. We could do the same thing. We are just going to say X is equal to 3 and Y is equal to 2, and then see what we get. So if I say 3 over 3 over 3 plus 2. Will you get the door real quick? So I'm doing this one here, just plugging in some numbers to see what I get. So that's going to be 3 plus 5. Now, in that same vein, I'm going to plug in, we'll do this in red. X is 3, Y is 2. So I'm going to do this one now. And I get 5 over X, which is 3. So I get 5 over 3. So that means that this one is greater than this one. Or this one is less than this one. So what I would have to say is X all over X plus Y, which is this value here, is less than X plus Y all over X. And you could do, there's some more math that you could do there, but basically this is the easiest way to do it. And you could do the same thing here, right? So we're going to compare on this side. I'm going to distribute this 2 through the parentheses. So I'm going to say that 2 times 3 plus 2. And I'm going to compare that to 3 plus 2 squared. Okay? Actually, I did that wrong. Let's draw these in different colors so you guys know I'm doing different colors. So this should be 3 plus 2 squared. So this is this expression, and I'm comparing it to this expression. So this is the same as 2 times 5. 2 times 5 is 10. This one over here is really 5 squared because 3 plus 2 is 5. 5 squared is 25. So then 10 is less than 25, or you could say 2 times the quantity X plus Y is less than X plus Y squared. That one was pretty easy. So when you get to these types of problems, and we're going to do some for our homework, sometimes it's easier just to plug in a statement that's true. In other words, X is greater than 2, X is greater than Y, and 3 is greater than 2, and then just do some math and see how it works. That's the easiest way to do that. There are more complicated ways to do that, but they're not algebra ways. Well, they are, but they